Hi, this is Kumaran. This is a new series for programming of 8085 microprocessor in assembly language. The same thing will be shown on the simulator also. So I hope it will be useful for the beginner how to write a program for basic arithmetic and logic operations. Let's start with the program. Before the programming, the programmer's model, which means what are the registers available for the 8085 microprocessor for the user. So here you know that 8-bit microprocessor, we have a 8-bit accumulator where you should have one 8-bit number, and the result also will be stored on this accumulator. This is the register A. We have a flag register to know the status of ALU. Then we have B, C, D, E, HL, 6 8-bit registers. Otherwise we can use 3 16-bit register pair B, C, D, E, HL. Then the stack pointer and program counter for system usage. So programmable registers we can use B, C, D, E, HL. So programmer model. Let's start the task of multiplication of two 8-bit numbers. So you know that multiplication of two 8-bit numbers. For example, we are multiplying that 4 into 5. The binary multiplication is the same as decimal multiplication. The binary 4 is 1 0 0, 5 is 1 0 1. So when you multiply this, we'll multiply that 1 into 1 0 0, it is 1 0 0 into this one is 0, then again it is 1 into 0 0, then 1. So add this, you will get here 0 0 1 0, then 1. So from LSB you adjust that 4 bits, and this one is 1, this one is 4, 1 4. So 4 5s are 20. 20 decimal, but processor is working on binary, so you divide this L16, convert, always look for hexadecimal answer. Then 116, remainder 4, the 1 4, that's why the answer we are getting in binary multiplication. This is what happening on multiplication. But when you multiplied that two 1-digit number, which means 4-bit numbers, we are getting answer in 8-bit. Likewise, when you multiply that two 8-bit numbers, probably we will get a 16-bit answer. But the one more thing is in processor there is no multiplication, subtraction, division. All this is performed with the help of addition only. That's what. So multiplication means it is a repeated addition. For example, we will take this 4 and 5. Anyone, for example, I am taking 4 as a count. We'll take this as a count here. Then we are going to add that 5 the 4 times, which means, so it will start with a 0, then add this first addition 5, the answer is 5. So next addition, the answer plus new 5. So here for every addition you decrement the count also once. So we started with 4, then count will be 3 here after decrement. So after decrement it becomes 1. Then the answer is 1 0 plus 5, and then the count becomes 1. Then 15 plus 5, the count becomes 0. So when our count is 0, store the result. So the result is 2 0 in decimal, which is 1 4 in hexadecimal. That's what we are getting. So the same logic we are going to implement in the assembly language program also. Anyone you can take as count, other we have to add with thing. See here we are starting with 0. That's why the number of additions we check, it is 1 2 3 4. So suppose you are adding that first number itself 5 plus 5, then we will have n minus 1 additions only possible. So that's your choice. You can either you can take as the count start with 0, otherwise you add directly with the first number plus first number, then you decrement the count by 1. So either way it will give the correct answer only. But in 85 microprocessor, when you multiply two 8-bit number, possible answer is 16-bit. So you know that when you use that instruction add, so it will produce that answer maximum 9 bit, 8 bit sum and 1 bit carry. So that's what possible, but we cannot accommodate 16 bit answer here. That's why we are going to use that DAD. So you know that DAD means double addition with RP, the register pair. So what the meaning of the instruction is, it will add that content of HL plus the register pair. The answer will be stored on HL. So only the instruction which will be used to perform 16-bit addition here, where the HL will act as accumulator here. So here the HL size is 16-bit, 8 into 8 maximum 16-bit. Easily you can accommodate the answer in HL. That's why we are going to use DAD RP in this programming logic for the multiplication of 8-bit numbers. So let's do with this. So as per the logic here, this number will start with the HL. Then the other register pair we can use, for example BC pair we will use. Then count we will use any other register apart from this. So HL BC, then we can use DRE here. D will be used as a count. So these are all the pre-request or pre-assumption what we are going to do. HL means it's 16-bit. Here it is 4-bit only, but 8-bit means also the L register. Both HL should be cleared to 0. Then BC pair means the C register should be loaded our one of the multiplier input. Then the higher register to be cleared to 0. Then only we can perform this multiplication. So these are all the tasks what we are going to implement in this. So before writing the program, let's assume that the data is available on the memory address 4200, 4201, 8050 correspondingly. When you multiply these two, the answer should be 16-bit. That should be stored lower byte on 4202, higher byte on 4203. That's what the task we have. Before writing the program, let's go through a instruction available in 85 microprocessor for data transfer group, arithmetic, logical group and branching. So if you are remembering this, easy to write the program. So as per our pre-assumptions, we are going to add that get the number from memory address 4200. To take the input, we use that LDA. You take that LDA. So let's change the color. Because it's already. So LDA it is 4200. Take the first number, one of the multiplier, and transfer to this to D register to count, take it as a count. Okay. Then next again you get the data through LDA. The same program you can write by using indirect addressing also. For simplicity, we are starting with this in direct addressing 4201. This copy to that another register, for example E register, because BC pair transferred to C from A. Now we have to clear that B register, MBI B register, comma 00, which is not clear. So now we have to clear that HL pair also, LXI H comma 0. Now we cleared everything. D register enabled as initialized with count, C register, and BC pair is having one of the input, D register as a count. Now we will perform that DAD, double addition, the register pair with B. B means HL plus BC, answer in HL. So for every addition we will decrement the count once. Here decrement is DCR decrement, DCR D register. Suppose JN is set, jump on no 0, repeat. The repeat is we have to add that addition is repeat, so the label should be here repeat. So as the mouse, it is a bit difficult to write, just about this my handwriting. So repeat here. So after that, the answer will be available on HL pair, that to be stored on the memory address, consecutive memory location. For that we use that SHLD. For 16-bit answer, writing, we can use that SHLD, the register address 4202. Next address we'll use 4202, then halt. So this is the program for addition up to 8, multiplication up to 8-bit numbers in this. So that's about the programming. The same thing we will implement in simulator 8051. 8051. Already in this simulator, how to work with, we have given a demo also. If you have not watched that video, you can get that in the playlist. So let's start with the programming. Same my LDA 4200H. Then we will type, it will be faster. Then move this to D register, move this to E register, comma A. So here you have to space move A. Again get the second data LDA 4201. Then move this to B register, comma, not comma here, space A. Move B comma A. Now we have to clear that other register in the register pair. So move immediate. Here we are using D pair. Use that D register to 00. Then clear that HL pair also. LXI H comma 0 0 0 0. Enter. So now we will implement the addition dad register pair. Here use that D, dad D. Then decrement DCR, which register, B register will use. Then jump no 0. Suppose Jn is that no 0 means label repeat. Then SHL, store the result on the external memory address 4202H. Then halt. So one more, the label is missed here. Label is here. You type that repeat colon and space, like this you do. So now we have to give the input also in this 4200. Here one of the input is 80. Then another input is 5E. Then the output location you clear 00. Now we will run the program, compile this, no error. We will check one by one. We can check the first number taken to accumulator, 80 is taken to accumulator. The same thing to be transferred to the E register. Check the E register here. Again we are going to take from second data in A, that to be transferred in B. Then the HL pair will be cleared. I hope I have click that continuous run. So it is repeating number of repeated additions. See that B register is 8 to 0. So till 0 it will repeat this numbers continuously. If it is 0, it will write the result next. That's what the program of 8085 multiplication of 2 8-bit numbers. So let's verify the output. B register reaching 0 now. The output is 2F00. The same thing you can compute and get the result. Yeah, that's it about multiplication program in 85. Thank you.